Hello friends, you all are welcome on this YouTube channel. This question, it has been asked in your EAC 2002 examination. Let us solve this. First, please read the question statement. The figure shows a network in which the diode is ideal one, right? The diode is given ideal, right? Now find the correct terminal voltage and current characteristics of the network, right? So did you understand the question? So this network has been given to you, right? And this diode, this is symbol of diode, this diode is ideal, it is given. This diode is ideal, right? V is the applied voltage and I is the current flowing in this network, right? So out of these four options A, B, C, D, only one option is correct, and you have to find out the correct voltage and current VI characteristics, right? So on vertical axis he has plotted voltage and on the horizontal axis he has plotted the current, right? So he is saying that the diode which is connected in the network is ideal one, right? So what is the meaning of ideal diode? Ideal diode means its cut-in voltage is 0, right? If it is a practical diode, then if it is silicon diode, then its cut-in voltage will be 0.7. So 0.7 volt will be the cut-in voltage of a practical silicon diode, right? So what is the meaning of this? The meaning is that when you apply at least 7 volt across it, it will then start conduction. It will be on, right? It will be on once you apply 0.7 volt for practical silicon diode, right? So but if it is ideal diode, then its cut-in voltage will be 0, right? That means as soon as you apply a voltage, it starts conduction, right? It will be on immediately, right? So ideal means no cut-in voltage. So cut-in voltage is that voltage at which your diode starts conduction, right? If it is a practical silicon diode, then you must give 0.7 volt at least, right, to make it conduction mode, right? And if it is a germanium diode, then you must apply 0.3 volt for conduction, right? So these are all the cut-in voltage for the practical diode. If it is a silicon diode, then the cut-in voltage will be 0.7 volt, and if it is a germanium diode, then the cut-in voltage will be 0.3 volt for germanium volt, right? For germanium diode. But if it is ideal diode, for ideal diode cut-in voltage is 0, right? And since cut-in voltage is 0 and it is given in the question, it is ideal one, so no cut-in voltage will be there for this diode, and as soon as you apply any voltage, immediately it starts conduction, and once it starts conduction, it will be then represented by a short circuit, right? It will be represented by short circuit, right? Now you can apply Kirchhoff's voltage law. Right? And find out the equation between voltage and current to plot VI characteristics, right? So I am going to apply Kirchhoff's voltage law. Please have a look at it. So this is the battery of 5 volt, right? This is a 2 ohm resistance. Current I is flowing in this network, right? Like this. So this bigger terminal of the battery is represented by plus sign, and this smaller terminal is represented by negative sign, right? So here apply Kirchhoff's voltage law in this, right, in this loop. So you start from here, so you go minus to plus, So when you go minus to plus, you will write plus V, right? In the direction of current, I told you there is a voltage drop. It is a basic convention that we follow. So drop will be represented by a negative sign. That means later sign will be negative in the direction of current flow, right? So current is flowing like this, right, from left to right. So that means the later terminal will be negative, and this negative shows the drop in the voltage, drop in this 2 ohm resistance, right? So plus V, plus to minus, minus 2 into I, right, minus 2 into I. So this is a voltage drop in 2 ohm resistance, right? Now next is, this is the diode which is ideal, so no voltage drop across it, right? So here you can write so voltage drop across this diode is 0. This is simple short circuit. So now come here, plus to minus, minus 5 volt, and you come back to the same point where you have started, loop completes. So plus V minus 2I plus 2 minus minus 5 volt is equal to 0, loop completes. So here you can write V is equal to twice I plus 5, right? So this is the equation of the form Y is equal to mx plus c, right? So can you tell me what is the slope? Slope m is 2, right? So which option is correct? Just have a close look at it. In this figure, the intercept is represented by this c, constant c. So you can also write this c. C is how much? C is 5, right? C is 5. So intercept on vertical axis is 5. Intercept should be 5 and slope should be 2. So which characteristic is correct? Just check it out. Intercept is 5 but slope is given 1 by 2, so this is wrong. This is again wrong, which is this, because this characteristic is existing in the negative side. Now here come back, see at this, see here, this is intercept is 5 and slope is 2, right? It cannot start from origin, so this is also wrong, this is wrong, this is also wrong, this is also wrong, right? So option C is correct. Intercept on vertical axis is 5, vertical axis voltage axis, horizontal axis current axis. So slope is 2, intercept is 5. So this option C is correct, right? Option C is correct. C is the correct option, right? So did you understand the question? Right? So M is 2 and this C, intercept on vertical axis is 5, right? So which option is correct? Option C is correct, right? Option C is correct. So thank you very much for all such kind of questions. You can subscribe this channel. Thank you very much. Thanks for watching.